Bismillahirrahmanirrahim. Is it shooting? Yeah. Assalamualaikum and greetings. Alishanmao here, and welcome to my little main cave and more RC reviews. In particular, more 3D RC helicopters. Yes, I have decided finally to give up all my radios and keep my beloved RadioMaster TX16S. I'm going to set up my KDS Innova 550, the big 3D helicopter. I mean, look at the size of this thing, okay? 550 size KDS Innova 550 with RadioMaster TX16S radio control. Not sure how do I do this video because there are a lot of things involved to set this helicopter. This is not something like M2 or Ishin E160. If you have helicopters like M2 or Ishin E160, these are completely built. Everything is completely set up already in the flight controller. All you need to do is program your radio and nothing else. Just program your radio and tweak the settings, bind the helicopter, fly, tweak, and have fun with that. But these helicopters that you build from scratch with a kit, nothing comes pre-built. So you build everything, literally, like, you know, the main rotor head, tail rotor system, mainframe, everything you build from the very scratch. You solder the connections for the motors and everything. This is going to be different compared to these helicopters. In these kind of builds, it's not just radio setup, but also the choice of your flight controller, which I found a very, very nice MicroBeast system. I used to fly my bigger helicopters with this. I believe KDS 700 size, even I flew with these. I believe it was installed on some of my bigger helicopters, KDS helicopters before. So I plan to go with this one, and this is going to be my very first time to set up MicroBeast with the OpenTx radio control, that is RadioMaster TX16S. So it's not the same that you just create a model and, you know, tweak the settings from there. You have to do every setting from helicopter side. There are way too many steps involved. So I'm confused. How do I carry on with this video? Do I show you everything step by step, how I'm doing the connections and things, what is happening at each step, the problems I'm having? Maybe yes, I should do it. It is going to make maybe an hour long or more video. But it's gonna be fun, and you're gonna find out all the mistakes I'm making, all the problems I'm having, and if OpenTX radio control is gonna work or not. I'll find out everything. So let's start working on KDS Innova 550 and set it up with the OpenTX RadioMaster TX16S. I'm going to use MicroBeast. Ba-bam! As you have seen, the MicroBeast flight controller. It's basically very easy to do. Everything is done at the flight control level. You just need H1 setup or simple airplane setup on your radio control. You just need a 5-channel radio control. Everything is set, no computer required, by buttons and switching the modes, and set everything step by step. I'm also going to use the Futaba SFSS system, so I'm not getting rid of Futaba completely. I have a Futaba receiver that is R2008SB Futaba receiver. Okay, now I can use S-bus, one line connection on, you know, BeastX. You know, everything how it goes, everything how it works. I'm just gonna go with the flow. So the step one. So I'm not gonna power the motor. This is a crazy powerful motor right here. It's huge, with a 120 amp ESC right there from Hobbywing. So I'm not gonna power that. I'm gonna power the receiver and flight controller using the UBAC, which is 7 amp UBAC UBEC, and it should be enough to power all the servos and receiver and flight controller. And I'll be able to, you know, do the setups. Once everything is set up, then we will power the motor on and see how things go. At this side, I'm running my, user manual for the BeastX, which is really a very long, user manual. Now it says the Futaba receiver can be connected with red, brown, orange, and channel 1 and 2. That's all you need. But I am thinking, why not go to down here, and it says Futaba S-bus receiver. Just connect to elevator DL1, and throttle servo will connect here, and if there are any additional channels will be connected there. Power supply will come to here. Now my ESC does have a built-in UBEC, so I will not need any additional power supply. Maybe one S-bus connection can power and everything. So first thing first, we're gonna make connections to the flight controller and receiver connections, and elevator DL1, which we decided to go with. Okay, let's say it is on elevator DL1, and it goes to Futaba S-bus connection right here. Ooh, did I break something? I heard some tick. Wait, focus camera, focus. So right here, the S-bus connection. Okay, da-da-da. Polarity is right. That's all she wrote, people. Connecting SFHSS with the MicroBeast. So now this is gonna go in the helicopter right here. Okay, and my receiver will go somewhere. So I'm just gonna add the receiver here, I think. Okay, so where's my double-sided tape? Here's my double-sided tape. Where's my scissor? Scissor, where are you? Come on, scissors. Scissors. Where is my goddamn scissors? I normally get this in local markets. This is really nice. Very, very nice quality double-sided tape. Just make sure to use them in time. If you keep them over a year or so, they become bad. Not that sticky. So, there you go. I'm just gonna, oh, sorry. Stick this one right here. These are hard. They don't provide so much vibration damping, which we don't need much as well. Remember that. So one little one will be enough for the receiver to stick somewhere. Where did I plan to stick the receiver? Here. Okay, so I'm just gonna go and stick one double-sided tape here to, take this one off, but anyway, I did it. And right here, stay with me, don't go anywhere. So this is gonna be like this, connections towards the rear of the helicopter, and this is towards the front section of the helicopter, facing the helicopter nose. So I'm gonna put it right here in the middle, where it shouldn't be pointing like, a little bit left or right, because you will have issues. So make sure you install it as straight as possible. And check this out. Why do I love this tape? I can lift the whole helicopter now. You just, just holding the BeastX receiver. Put the receiver right here. Okay. Later I will, arrange the cables here. Good. Now it's time to connect rudder servo, which is gonna go to channel 4, obviously. So I'm just gonna what I'm gonna do is I'm gonna run this cable from under here. Now I'm worried that this carbon fiber may cut the cable. So what I do normally is very, very simple. Okay. Let me just zoom in so you know my worry, what I'm talking about. So this is what I'm talking about. Here, carbon fiber is really very, very sharp. Now you can file it down, or a simpler way is just to add a double-sided tape right under where the cable is going to be. Okay, and just like this, stick it. this has worked countless times for me, okay, and always have saved my cables from cutting due to the vibrations while they are touching the, you know, the carbon fiber sharp edge right there, countless times. So, and by removing that, I can actually stick the cable here on this. So cable will not move, will not cut, and once it's connected to signal up to channel 4, and then I just connected to channel 4 on MicroBeast X. Let me show you right there, channel 4. Now, because the swash plate here, let me show you very clearly. One moment, I have to tilt the helicopter to you. Okay, now look at that. That you have 1 servo, 2 servo, and 3 servo. So it's basically this way, okay? This is called 120-degree swash plate. All right, so this is 120-degree swash plate, and it has a certain, order to connect your servos to the BeastX. So once again, I'm going to describe it to you. 1, 2, 3. So it's this kind of angle. You can also see the picture. Back servo here, rear servo channel 1, left servo channel 2, right servo channel 3, and we're just going to connect them to channel 1, 2, and 3. You can see clearly channel 1. Channel 1. Okay, this servo, the left servo, is your channel 2. Nicely, this is channel 2. And obviously the last one, the right servo, and this is the channel 3, the right servo. That's all she wrote, people. S-bus on DL1 or elevator to S-bus receiver, rear servo to channel 1, left servo to channel 2, right servo to channel 3, tail servo to channel 4. Now, helicopters this big, you don't want to power the motor when you're doing the setup at your home. Take it as a warning, because this motor is way too powerful. You're dealing with 6S batteries, more voltage here. So do not power your helicopter system with the ESC yet. You can do UBAC because you just need to power servos, flight controller, and the receiver, and that should do the job. After that, your channel 3 from the ESC will connect to channel 3 on your receiver. It will provide power to the flight controller, and also control the throttle. So that's going to be later, and obviously I'm not going to use that because that's going to just power the motor and the system. I'm just going to power the receiver and flight controller using the UBAC, because all I need right now is the servo movement and setup of the flight controller using my radio control, and I'll be perfectly safe because the motor is not going to spin anything at all. We will be doing all the setup using the radio and the flight controller, making sure movement on the channels are right, corresponding channels are assigned properly, flight modes are assigned properly, and the most important is pitch setup on normal flight mode, idle up and idle up 2 flight modes, and pitch setup on tail rotor, and proper setup of the frequencies of the servos. My swash plate servos are 200 Hertz frequency, and the tail servo is 333 Hertz frequency, and these frequencies are very, very important. If you set up the wrong frequencies, you're gonna burn your servos. If you do not know the frequencies of the servos, the best thing to do, if you're using MicroBeast or any other flight controllers, best thing to do, leave the frequency on 50 Hertz, which is kind of universal for all servos, and that will be okay for. If you need more response, you really want to get everything out of your servos, go with the right frequency if you know according to user manuals. Now the next step is for me to set up a model on my RadioMaster TX16S, and I will just copy the helicopter model I created for E160 and tweak it from there. So this is going to be very easy. If you want to know how to program the OpenTX radio control for your helicopters, 3 helicopters, using the H1 or normal airplane setup mode, where the flight controllers do everything, go ahead, check out this video tutorial that I have posted. A long video tutorial shows everything step by step how to set up OpenTX RadioMaster TX16S for 3D helicopters. So once you've done that, all you need to do is copy the model, pump to a new model, bind it to your receiver, tweak the settings from there. So that's what I'm gonna do. Let's do it. Bismillahirrahmanirrahim. The very first time, OpenTX.
Welcome back, alishanmao. Fly it like you stole it. Have fun.
Switch warning. Flight mode normal. Whippets dual rates off.
Okay, so I have just copied the same setup from the video that we have watched for my M2 helicopter, and now all I need to do is, one moment, let me make sure you are watching everything clearly. So model select by pressing and holding the dial. First time it takes time, but later, everything just starts moving very fast. Now, E160 was a model that I set up before in that video that you have watched, long video tutorial. And then M2 Explore was a copy.
3 minutes.
So I'm just gonna, shut up, the timer is running. I'm just gonna duplicate the M2 Explore and select this model.
Switch warning. Flight mode normal. Whippets dual rates off. Throttle disabled.
Okay, now I'm gonna describe everything later, but if you want to know the details, go ahead and check out the...
Telemetry lost.
Yes, I know. Go ahead and check out the details on how to set up this model and everything properly. But I'll take you step by step on this setting. For now, what I'm gonna do is I'm gonna remove this picture because I haven't copied the picture of the helicopter yet. So I'm gonna remove the picture and rename it. Okay, KDS Innova 550.
Telemetry recovered. Telemetry lost.
Oh, come on, man. How do you have telemetry recovered? Already glitching on SFHSS. Don't scare me. So, multi-protocol SFHSS, and we're gonna bind the receiver to the radio now. Making sure the polarity is right. So, here we go. 5 volt, and I'll power on the receiver now. There you go. My receiver is on, servo's moved, my BeastX is on, some lights are moving around very beautifully, and I need to press a button down there. Now, there you go. You have to press and hold the button right there, okay? And then solid green light means it's bound. Nothing will work because we haven't set up the... Shut up. We haven't set up anything on BeastX. As you can see, the lights on BeastX, they're dancing. Can you see them? One more very important point you need to remember here. Before configuring the BeastX, it is recommended that you do not connect the servos. And if you do want to connect the servos, before powering on, make sure you have removed the servo horns. Do not install the servo horns. Do not add any kind of connecting rods, because if something goes wrong, your servos will bind, heat up, and get damaged. So this is a very, very important tip. Remember, do not add control horns on the servos, okay? And then if you remove the servo horns, there are no servo horns, there are no connecting rod, then you can power it on and safely configure your parameters on the BeastX. Now, let me take you to the next step. For the radio control programming, what kind of OpenTX radio control programming is running in it, you can watch, because it's the same thing. I haven't changed any settings yet. I just copied the model. You can watch my setup tutorial on OpenTX radio control, RadioMaster TX16S, setting up Ishin E160 helicopter. Watch that video and you will know what kind of settings are running. After I have set up everything, when I tweak the settings here to match this helicopter, I will take you step by step on each and every setting in this video, so stay with me in this video. Okay, now in this step we're going to set the receiver type, and to do that you have to press and hold the button on MicroBeast and turn on the power, and you will see the yellow LED flashing on A yellow LED is flashing. Now the LED color will here, I believe, will show you the type of the receiver. Off means extended. We are looking at red flashing, so press and hold for 2 seconds. No, this is not the color. Press and hold for 2 seconds. Yes, red flashing is the Futaba S bus. Press this button briefly, and now you're on B, and your setup, receiver type setup has been saved. Turn on the receiver, turn on the radio, and if your connection to the receiver is nice and your setup is right, that is Futaba S bus red flashing LED we just selected, you should have a blue LED here that shows everything is okay at this step. So after this setup, next is the channel assignment, and I'm going to take you here. My channel assignment, I'm not going to disturb it. Futaba S bus, channel 1 aileron elevator, channel 3 is throttle, channel 4 is rudder, channel 5 tail gyro gain, channel 6 pitch, channel 7 is auxiliary channel 6, which we are not going to use. We're going to use this on changing the pitch on channel 6 and channel 5 tail gyro gain, which will also probably change our flight modes. Okay, now we're going to set up the orientation of the BeastX mounting. So press and hold this button until A is solid. Now move your rudder. If it is red, means it's a standing. For the flat, it should be blue. That's it. That's all she wrote. Next, you have to set up the swash plate servo frequency, which is blue for 200 Hertz, which is obviously my swash plate servo's frequency is. So if you want to change it, you can.
Telemetry recovered. Telemetry lost.
Shut up. You can change using the rudder.
Telemetry recovered. Telemetry lost.
This is gonna keep saying it because I'm way too close to receiver. Sorry for that. Just remember that now we are on a blue, which means 200 Hertz frequency for my swash plate. Done. If you have user defined, you need to have a PC software for user defined. Otherwise, just leave it on 50 Hertz. Okay. Press. Now is the tail servo center pulse width, which is blue means 1520. Which is D. Now on this step D, you have to set the frequency of the tail servo. Okay, and my tail servo is 333 SZ, and for that the blue is flashing. Blue light flashing means you have set it right. If not, you can move the rudder to set it to different one. Okay, so for instance, blue flashing means 333 SZ. That is the frequency of my servo, and I'll leave it right there. Okay, now you can see that we are on setup point D, which shows the 333 Hertz frequency for the tail servo that I have selected. And also we have, on previous step, we have selected the center pulse width. And at this moment, the BeastX is going to give you plenty of time to adjust. It will not exit this. And you can set the frequency right using the rudder values, rudder stick on your radio. At this moment, you also have to connect the connecting rod to the tail rotor and install the tail blades. And you have to connect the connecting rod to the servo, that is the tail servo. And for that, you can see down there, you can see that it's almost perpendicular, 90 degree to the servo. Okay, just like this, 90 degree. All right, so the servo horn is like that. And you have to increase and decrease the length of your connecting rod. So when you connect the connecting rod, you should have slightly positive pitch on your tail rotor to compensate the torque roll, because the helicopter will have a torque roll. So you need to make sure which way the helicopter, once the motor is armed, which way the rotor moves. Okay, now the main rotor is moving clockwise, and obviously it's gonna, you know, have a counter torque roll. And to counter that, as the blades are spinning the clockwise from my direction as well, I will have to have slightly positive pitch to compensate the tail going from that way. And you have to do that. You have to do that by manually, physically increasing the length of, or decreasing the length of connecting rod. So I have done that. Let me just quickly connect the balls to the connecting rod. I'm going to connect a rod onto those metal balls. Okay, on the same step, that is D, and I have slight positive pitch on my tail rotor. That's that. Let's move to the next step, that is to set the endpoints of the tail servo. Okay, next point is to set the endpoints on the tail servo. So I'm just going to press the button, which will move our setup to E. All right, and now using the rudder stick, you have to move the rotor blades to their full, and then slightly, you know, slightly back off. So I'm just gonna keep it right here. Okay, just make me do the things right. So I'm just going to keep it right here, and every time you make a setup, you will see the LED here will blink red or purple. That shows that it has saved one side of the setup, and then you move the rudder stick to other side and it will show the setup, saving setup on the next side. So for instance, if I move the rudder this way at one direction and leave the rudder, you can see it has saved one side endpoint all the way to other side. And I don't know if you can see it not, but it has turned kind of red and purple mixed. So now let me show you what I'm doing here on the tail rotor. Okay, so watch as the tail rotor changes pitches. What we'll do is move it all the way one side, and once I'm sure it's binding the full movement, I will move slightly back from that, so it will not bind at its full. Okay, and leave the sticks and wait until the LED shows that it has saved the setup, and then I will move to the other direction slowly, full binding, and then move slightly back. Okay, and once I know where my endpoint is, I will leave it right there, and the LED is solid purple here. That shows that my endpoints for the rudder servo have been set. Now on the next point, we will set the sensor for the tail servo, and to do so you have to move the tail and see if the rotor is countering that direction of the rotation or not. Now I can see when I pull the tail to myself, the rotor, the way it will be moving and the way it changes the pitch, it will actually push the tail in the same direction. So basically this is wrong, and for that I need to go and change that direction. So I'll press and hold the button, and we'll keep pushing until we go to F. Okay, now here's blue LED, and what I'm gonna do is I'm gonna use my rudder stick to turn it to red. So I have just reversed the direction of the sensor. So when my tail pulls towards me, that is clockwise direction, okay, rotation, the blade changed on the tail rotor blade. The pitch changes in a way that when the tail rotor is spinning, it will actually counter this torque, as you can see now. Okay, so as I move the tail, my tail rotor blades, they change the pitch in a way that they will counter this rotation of the the whole helicopter, okay, and provide a tail lock. Now the next step is really very important, and how well your helicopter will actually fly and respond to pitch curves depends on this very critical step. Now on the G menu setup on MicroBeastX, you will have to center each and every swash plate servo. That is, we have 3 servos, channel 1, 2, 3. We will be using the rudder stick and elevator stick to center these servos, and to do so we'll also be using the horns, servo horns, and we will install them first after turning on the power to the flight controller. All the servos will be centered. Then we will install these servo horns and make sure that each and every is perpendicular 90 degree, as close as possible after installing. If not, then we will use the rudder and the elevator sticks to move each servo individually up and down until we have these servo horns exactly 90 degrees perpendicular. And once they are on each servo, then we're going to install the connecting rods on each servo and make sure that our swash plate, because the servos, all servos will be centered, we will make sure that our swash plate stays level, and installing the main blades, we will also check the main blades pitch should be exactly 0. That's a very important thing. So we will turn the power on to BeastX, go to the G setup point. All 3 servos, 1, 2, 3, will be centered, and then we'll install the servo horns, making sure as close as to 90 degree perpendicular to each servo orientation. And then we will use the rudder and elevator to individually set each servo horn to exactly perpendicular 90 degree, as close as possible. And then we will install connecting rods, and we will have to decrease the connecting rods length manually, physically, until we get the swash plate set up leveled and main blade pitch to 0. Both main blades should be at 0 pitch. Very critical step, so you have to pay attention and you have to spend time on it. So for this step, I'm going to install the main blades, these nice blades, and they're really very sharp, and they have like machetes right here, man. Ooh. Anyway, so very nice straight line right here. I have my pitch gauge, okay, so this is a digital one, does a very good job. Power on everything, so press and hold the button. Solid light A, B, C, D, E, F, G. Alright, once again, check it out, it's on G. These are inside, so these are for these. Now as the servos are centered, what I'm going to do is I'm going to make sure once this fits in, it should actually makes a straight or as close as to 90 degree. You can see right here, it's this top is exactly perpendicular 90 degree, but not the bottom. And if I try to move that slightly down, it doesn't fit, and it will fit because of those grooves only this way, because of that things, the cuts provided there. So my job is to find where it fits as close as to 90 degree, as you can see right here. Once again, if I remove this and try to put it down, it doesn't fit, and if it fits, it goes down this way, which is not 90 degree. So this position is as close as to 90 degrees, and still I need to push it down, slightly down a little bit, and that's where I'm going to use the elevator and rudder sticks on my radio to move it down. So you can see this one is almost as close to 90 degree. Just I need to do slightly lower. The third one. The third one, I will have to carefully move everything, making sure I don't drop my beloved RadioMaster. lower is much more deviation to 90 degree. This is much more closer. I have to put it downwards slightly. I'm not sure if you can actually see it from this camera, but if you like, I can, just for the sake of the tutorial to be really very clear, I can show you with this camera. So right there, you can see I have to put this one slightly down. So now we will go to the setup and do every servo, move every servo individually on G, and make sure the arms are exactly perpendicular, 90 degree perpendicular, the servo horns, okay? So once you move the rudder, the servo actually gives you notification by moving up and down, so you know which servo you are actually moving. So right now I'm on this servo, and I'm just gonna use my elevator stick to put it down a little bit. Oh, this is going up and this is going down. Let me see, call it exactly 90 degree according to the way I can see it. Now I come to this servo. Basically what I'm trying to do is just eyeballing it, which does the job, and trying to put the metal ball exactly in 90 degree perpendicular line, how things are moving. Okay, so this is the servo and I've selected, and I need to move it slightly down, and you can see when I move the elevator stick on my radio, it will go down a bit. Oh, this is going up, it's going down, down. See, you can move it up and down as you want, right? So slight adjustment is exactly almost, yeah, right there. Exactly 90 degree perpendicular. That's what I feel just by eyeballing them. So now all the servos are done. Okay, and once you exit, everything actually goes to center, saved, and now you can install the connecting rods. Alright, so this step has taken me about half hour, trust me. Now you can see that the swash plate almost leveled here, okay, and by eyeballing it only you can see the swash plate leveling, and we can also see the blades are almost 0 degree, should be 0 degree, as these two are also perpendicular. So far this one you need to do the geometry as close as possible and try to level. I wish I had a swash plate leveler, then I could actually do much more precise things. I might have to download and 3D print one, but so far by eyeballing it I can see everything looks very nice and leveled, and my blades are almost at 0 degree at this point. So this is done. Let's move on to the next step. Now comes a very interesting part, and that is a swash plate mixer. So we have, as you have seen, we have the 120 degree swash plate. Okay, so I'm gonna go push the button, and there's GH. I'm gonna go to H, and swash plate mixing, the LED shows red, which is 120 degree, and I'm very happy with that. If you want, you can actually change to whatever you have. Red solid is the swash plate 120 degree according to the user manual. If you want to check, come out here, the color and state of the LEDs. Okay, for red flashing is 90 degree, red solid 120 degree, which is by default is set as well, and I have set it up accordingly. Next step is to check if the swash plate servos are moving in the right direction. I don't know if I have to do the reversing on the radio or not, but for now I'll just check. So go to I, and I have to check the servo direction now. Now this step is really very easy. All you need to do is move your throttle up and down, and if your swash plate is moving up and down, the direction is not important. Up, going down, and if you push the stick up and swash goes down, or push the stick down, swash goes up, that does not matter. But when you move this, swash plate should go up and down. This means all three servos move together. At the moment they are not moving, so I will do a little bit of rudder. Okay, reverse one servo. No, it's still not good. Reverse another. No, still not good. Reverse again. And yes. Now we are moving all the servos in same direction. Okay, using the throttle. Now that we have made sure the servos move in the right direction all together, we have to check if my elevator aileron inputs are right. So my aileron inputs are right, right is right, left is left, but elevator back should be back, but it's going forward. So this is what we need to do in the radio programming, and that has to be reversing the elevator. So I'm gonna go to outputs, and my elevator is channel 2. Okay, and I'm gonna select, go down here, reverse, done, and check. Back is back, right is right, left is left, forward is forward, and our pitch is also changing. Now the next step is to teach the cyclic pitch. Okay, that is a pitch geometry to our BeastX on this helicopter. So I'm gonna go to I, and without moving anything at the moment, we should attach a pitch gauge, and have to have our blades on 0 degrees at this moment. We can set by moving the aileron elevator sticks, aileron only. We will change the geometry, change the pitch of the blades, and set them to 6 for now, plus 6, positive 6. Okay, so let's do it. So without touching anything, I have attached a pitch gauge which is showing me 0.7 minus 0.7 pitch, which does not matter. I will actually change to positive 6. So 3, 4.4, and 6.8. Sorry, go back. 5.8, 6.3, 6. All right, 6 right there. And the LED should be blue. If the LED is not blue, this means your helicopter's fly-barless geometry is not matched with your BeastX, and you have to, redo the either shorten the linkage rods, or do something which is much more headache. But if you have a blue LED, everything is good. Your swash plate or your helicopter swash plate geometry is perfect for fly-barless setup, and that is the blue LED showing right here. Now we can move on to the next step, which is K. All right, and now you will set the maximum and minimum pitches of your blades, and for that you have to remove any kind of pitch curves. So right now I'm in normal mode, and I have removed the pitch curve from here. As you can see, my pitch curve setup added, I have removed the pitch curve. There's no pitch curve right here, and I can actually adjust the pitches using the throttle. Okay, so I will go ahead. This is down all the way, which is kind of going reverse, and I don't want it, so this can be set later, of course. So we're gonna go to give it maximum 12 pitch. Okay, I want to have maximum of 12.2. I'll just keep it here. Okay, 12.2 pitch. Awesome. And we'll push the button to save the configuration and go to the next setup, that is L. So right here, this setting have been saved already. Now at this point we need to check if our servos are binding, and limit their movement using the rudder stick on your radio control. So I'm gonna go back and see if anywhere my servos are binding or swash is limiting, and I can use the rudder stick to move it up and down to its maximum position. So where I feel it's not binding, I'll just keep it there. It's binding here. I can hear the servo buzzing, means it's safe. It's binding, so I'll keep it where it doesn't bind. Okay, so basically you can always come back to these stages. If you change setup on any of the stages, you can always come back to these stages. Next step is edge, that is the swash plate sensor direction, and you will do this checking by tilting the helicopter. So if it tilts left, the servo should move in a way to keep the swash plate level. If not, you will have to, reverse the direction. Moving the rudder stick should do this job. Red, still not good. Purple, still not good. Off, now is right. So moving left and right, it actually adjusts, but forward and backward is gone wrong now. So check, wrong, this is right, and this is right as well. So the swash plate sensor direction has been set properly. As you can see, it actually moves in the right direction. The servo, aileron side, and pitch side, roll and pitch side, both are actually countering the movement. Now I have to use this camera because I cannot do with one hand. This setup requires both hands. In this menu N, this is a period compensation, so your swash plate is tilted forward. Okay, now you have to rotate the helicopter and your swash plate should maintain the same forward tilt. If not, you have to reverse the direction. So let's check. I feel swash plate is basically moving wrong. So I'm gonna use, very carefully, reversed direction using the rudder stick. And now it actually maintains the same posture. Press the button and everything is done here. Exit. Okay? Everything is done here, exit. But this setup is done, but you can see that having to have negative position down, I have positive pitch. And now I have negative pitch by putting it up. So this has to be reversed. Okay, everything is set. I just had to reverse the pitch, okay? And after reversing the pitch, you can see swash goes up, down. I have to decrease some of the values as well. And to limit the swash plate movement, I can now, I don't want to go back to the setup in the BeastX right now. I can again do it very, very easily, even on the field, to limit the swash servo movements, but I would rather do that now from the radio side. For now, everything is working, no binding, nothing, everything fine, and we are ready for flight. So now the next thing on the BeastX, as you can see from the user manual, dial and tail gyro gains will do outside, okay? Direct cyclic feed forward, tail dynamics, tail gyro gain. Right now I have set it accordingly on my radio control so that the tail gyro switches to rate mode on idle up and idle up 2, and heading lock mode in normal flight mode. I can always keep it in heading lock mode in every idle up mode or every flight mode, or in rate mode in every flight mode. This I will decide on the field, and easily can be done at the radio side. Now in the parameter menu we have A to N, things to set like swash plate cyclic center adjustment, control behavior, which we can choose from normal, sport, pro, extreme, swash plate pitching up compensation, tail heading lock gain, stick dead band, tail torque compensation, revo mixing. This all have to be set during and after the flight as per flight behavior. But for now, I can do swash plate cyclic center adjustment and control behavior to Pro mode, okay, because I'm gonna perform the 3D. So let's go do that. And for that, we need to enter the mode using this switch once again. A moment, give me a moment, and press briefly until you see the LED is very fast blinking. So now you are in swash plate cyclic center adjustment. At this point, swash plate cyclic center adjustment, you can easily do, instead of, you know, individually for each servo like you did in G. Okay, one moment, let me get out of these curves so I don't bother anything. Now you just need to move aileron, elevator up and down to adjust and make sure the swash plate is leveled here. So I see the back is slightly down. I can put it up, adjust it, and from here I see everything is properly leveled. So I'll leave it here. You can always do left, right, up, down, and the servos will move, and you can set the cyclic center right here. Next step is B, and that's where I said you have to select the control behavior, which is red. Flashing means a sport and red is pro. So flashing in the sport, I used to fly 3D with this one. I'll keep it in sports, otherwise I can always, you know, make it pro. Well, let's keep it at sports and pro will go later. Okay, so I will keep pushing everything until we get out of the setup. That's all she wrote. That's all the setup we needed at the moment on the BeastX right here. Right, I powered off everything. Everything is working normally. The setup until here was simply a breeze. I did learn a thing or two regarding some of the changes that I had to do. Obviously, next step, I'm going to show you what is my current setup, all the options from step 1 to step, say, whatever, on my radio control, that is RadioMaster TX16S. I'll show you every programming step by step and my settings, so you can actually copy those settings if you want and if you're using the BeastX. And after that, the second step is obviously connect the throttle control to the receiver, connect the motor and check the motor direction, set it accordingly, reverse or whatever, by, you know, just swapping the cables. Once the motor is working, next step is to, you know, set everything right, neat, all these hanging cables, tuck them in and make sure nothing is gonna get into anything and get damaged. And then it's time to pick my radio, RadioMaster TX16S, put in a fully charged battery, bring the helicopter out and give it a first flight. I'm not gonna do 3D right there because there's tons of tweaking to do when it comes to, you know, helicopters that you build from scratch and set it up with BeastX. Tons of tweaking to do. I will be watching how it flies, how it maintains its position, I mean, how the cyclic behavior is, how the tail is behaving. Forward flight, we will see if it is doing the dolphin movements. I mean, there's a whole lot of things to tweak until you are at the point where you will say, let's rip some 3D. So stay tuned for next videos of outdoor flight testing and tweaking, and I'll obviously keep you along with me, take you along with me with each and every step and show all the settings that I'm doing, settings changing that I'm doing on the TX16S radio control and settings that I'm doing on the BeastX side, and how the helicopter behaving and how I'm tweaking everything step by step. And once everything is set, then 3D on this helicopter is gonna be fun with RadioMaster TX16S. So stay tuned for more videos. Thank you very much for watching this lengthy video, and give it 2 thumbs up please, because that's a lot of work right here. I didn't show you the build of the helicopter, sorry, I didn't have time, but I have shown you how I set up the BeastX, MicroBeastX and RadioMaster TX16S. Thank you very much once again. Let's move on to the next steps. You know what to do. Hit that like button. It's right there. I know you can do it. Oh, while you're at it, also hit the subscribe button. Right there. Come on, don't be shy. Just hit it. Thank you very much for all your support towards my work, that I post regular and fresh content on my channel just for you. Hit that like button right there.